In this lesson, now let's tackle about kinematics. And we know that kinematics, this is one of the branch of the dynamics. And then under the kinematics, there is what we call a rectilinear motion. And there is two kinds of rectilinear motion. It is either horizontal motion or it is a vertical motion. At this point, we will be talking about. Let's focus on the horizontal motion. So when we say horizontal motion, it refers to a motion along a straight line, as along a straight horizontal plane. So for our last topic, we already discussed. It was already stated in your module that there is what we call a uniform motion, in which this means it is a constant speed. It has a constant speed. Any problems in which the speed is constant, therefore there is no acceleration, then we can say that that is a uniform motion. And the formula for it that you will be using is a displacement will be equal to the velocity times the time. Again, please take note that distance and displacement, they are the same in unit, but they are both different in terms of quantity. So at this point, we have there's what we called also a uniformly accelerated motion, in which the velocity increases uniformly. So the equations that we will be using here is we have three equations. So how did this equation derive? Actually, there is just there is a derivation for this kind of formula. It's just a direct substitution, or we are using the formulas for the uniform motion and others. So I will provide another video for it so you can understand how did these three equations derive. So at this point, S will be equal to the derived equations for the uniformly accelerated motion is here. The first one is the displacement is equal to the initial velocity times time positive negative 1/2 at squared. And then the second one is the final velocity minus the initial velocity will be equal to positive negative times the acceleration and then the time. Then the square of the final velocity minus the square of the initial velocity equal to the positive negative 2 times the acceleration and then the displacement. So here it is. S here again is not speed. I designate S as our displacement, or the distance traveled, or the displacement at time t. V sub I is the initial velocity. And then take note that in initial velocity, it is automatically it will become zero if it came from rest. Okay, so one of the thing that you must note that if the problem has no initial velocity, but it stated that it came from rest in horizontal motion, then we could say it automatic that the initial velocity is zero. Then v sub f is the final velocity and a is the acceleration. Now there is also a note here that you are going to, as you can observe in our three equations, there is a positive negative. So how are we going to use how are we going to identify or know if we will be using negative or positive sign when we are solving? So here is the answer. You are going to use positive if the problem if any object or the problem shows that it is accelerating. It means that the velocity is increasing. So let's say for example, if we have 2 meter per second, it increases to 3 meter per second, so that is an accelerating example. And then you are going to use decelerating negative for decelerating motion in which the velocity is decreasing. Let's say for example, from our initial velocity is 4 meter per second and our final velocity is 2 meter per second. So at that point it decreases. So that is the difference. So now let's try to have our example. Okay, so for our example, so we have here our example. So it was stated here that a train changes its speed uniformly from 60 mile per hour to 30 mph. And so take note that when when you see like what you can see this a unit like this mph, then it is automatically means this is a mile per hour. So if you have kph, that is kilometer per hour. So in our first example, a train changes its speed uniformly from 60 mile per hour to 30 mile per hour in a distance of 1500 feet. So what is its acceleration? So our answer should be this one. So at this point, first thing to do, one of the most effective kind of answering a particular problem, first you're going to analyze the problem. So yes, just analyze the problem. So I think you can, and then the next step is you're going to identify the given and the problem. So here, let's identify the given. We have our 60 mph here, or mile per hour. This is our v sub I, or our initial velocity. 30 mile per hour, this is our final velocity. Then we have a distance, or this is our displacement. So 1500 feet. Okay, so this is D, or this is also S. Okay, so what is asked, the next is to find what is asked in the problem. Now, what is its acceleration? So we will be finding what would be our acceleration. So now, in order for it to solve, since we already know that this is a uniformly speed, or uniformly accelerated motion, because the velocity increases, or the velocity is, it states here that the speed uniformly from 60 mile per hour to 30 mile per hour. So then at this point, what would be the formula that you are going to use? So by inspection, so I have already stated here the three equations. So if we have equation number 1, equation number 2, equation number 3. So now, based on our given, what would be the formula or the equation that we will be using? So here, so by inspection, v sub I, v sub p, v sub f, and then our displacement. So let's going to find the equation that is suitable, or that will fit for these givens in such a way that the only one that is unknown is the acceleration. So I think we got the, the third equation, because v sub f, this is check, v sub I, this is check, and then our displacement, check, acceleration is the only unknown. So we are going to use equation number 3. So at this point, just use its let's use this formula. So our v sub f, this is 30, and then our v sub I is 60, and then so what would be the sign I will be using? Is it positive or negative? So again, let's focus on the final and initial velocity. If it's decreasing, then we will use negative. If it's increasing, we will use negative. So at this point, from 60 to 30, then we can say that the velocity is decreasing, so we will be using negative. Then 2, acceleration is what is asked. Then our displacement is 1500. So now, at this point, when we see this kind of problem, there should be, in physics, I know it is a good reminder for us that in physics there should be a consistency of units. If you're going so in terms of the distance, if you're going to use miles, everything that you're going to be using, it should be in miles. Or if you're going to use it in feet or in meter, everything is in meter. So now, as you can observe here, this is already mile per hour, and then this is mile per hour also, and then this is in feet. So now before we before we substitute the displacement, we must convert this first into a mile unit. So 1,500 feet. So what is our conversion? Our conversion is in every 1 mile. I think based on my research, so there is a 5,280 feet. So therefore, we have a 0 point. So feet will be cancelled out. We have 0.28 mile. Yes. So therefore, at this point, so let me erase this one first. Okay, so now we will be using 0.28 here. Okay, so using your calculator, so just a little bit simplification for this. I know you know how already to simplify this kind of problem. So this is just a basic simplification. So overall, if you're going to use your calculator, our acceleration will be equal to 4,821.43. This is per mile per hour or square hour. So mile per hour raised to 2. So now this should be our answer.